four-color theorem. Four-color theorem states that an area of a map can be filled with only four colors so that no two adjacent shapes or countries have the same color. This is found to hold true for any map, regardless of size or complexity. The basis of four-color theorem extends back centuries before any mathematical proofs were developed, originating from cartographers attempting to color maps with as little colors as possible. In 1852, Francis Guthrie observed this problem and became interested in finding why this happened, forming the basis of the conjecture. Guthrie's professor, Augustus de Morgan, was the first to attempt this theorem in 1852. However, he was unsuccessful. Sir William Rowan Hamilton was notified of this problem by De Morgan and found difficulty in attempting to prove this conjecture as well. Arthur Kemp was the first to publish a paper in 1879. However, there was found to be errors in his attempt by Percy John Heywood. Heywood took this and published his own paper on five-color theorem, making a significant step forward to proving the four-color theorem conjecture. It wasn't until 1976 in which Appel and Haken published the most universally accepted proof for four-color theorem using reducibility methods. A collection of points connected by lines forms a network. Representing a map as a network can be easily seen by doing this. At the center of each country, there are 4 points, with lines joining the points where the countries share a border. This transforms the conjecture to a network problem, allowing mathematicians to prove this through a field that was already well known, relating to knots and topology. It was by doing this that Appel and Haken were able to prove this theorem. The first major mathematical proof aided by the computer was the four-color theorem. This problem was reduced to a set of 1,936 networks that represented every possible map, which were then tested by a computer to see if they were able to be filled by four colors. Using a computer for mathematical proofing was considered controversial at the time and considered to be invalid. Nowadays, many proofs are assisted by computers. This was only made possible by the foundations that four-color theorem had laid.
Hi, this is the editor guy. So we had a bit of time left, and I thought what I'd do is go through a proof of a simpler but also related problem to the four-color theorem. So what we're going to do is prove that every map can be colored with 6 colors or less. So the first thing we have to assume is that there is a country on every map that is connected to 5 or less other countries, and that's just a fact that we have to accept. It can be proved, but we're just accepting it for now. So what we're going to do is assume that we have a map that is the smallest map that requires 7 colors. So we're assuming we need 7 colors to color our map. So we look at the map and we take away one of the countries that's connected to 5 or less other countries. So once we do this, we've got a smaller map, and so we can actually recolor it, and we only have to use 6 colors because before we had the smallest that needed 7. So now if we have a smaller one, we can use 6. So we then we put the country back in that we took out, but it was only connected to 5 other countries. So we've got a 6-color spare that we can use for that country. And what this actually shows is that the original map only needed 6 colors to begin with.